This year, on 9277, we've been working really hard on some very innovative control systems to maximize our robot's reliability and enhance the already rich learning experience that First Tech Challenge offers. First off, a robot needs to be able to drive by itself and autonomous really reliably so that we can make some of the precise maneuvers that are required in our auto. To do this, we use a combination of the built-in encoders and gyroscope and a custom PID function to allow our robot to both drive to a specific position and turn to a specific angle with insane degrees of accuracy. To have a really successful autonomous period, we needed to employ computer vision to detect how many rings were placed in front of the robot. Using the camera mounted on the front, we built a vision algorithm to detect the number of rings without taking the easy route, and using a library such as OpenCV or Vuforia to do so. The way this works is actually really cool. First off, we use something called a cluster recognition algorithm to locate the rings in the image. This algorithm is a staple of many machine learning systems, and basically, what it does is sort a given number of randomly scattered points on a 2D plane into a given number of clusters, and finds the center of those clusters. We used this to identify clusters of yellow pixels in our image, one of which has to be the rings. Using some logic, we then identify which one of the clusters found appears to be the rings, if there are any, and then simply measure the width and height of the cluster to determine how many rings there are. This algorithm has been very successful so far, and we've learned a lot about various computer science subjects in the making of it. However, this algorithm was not quite innovative enough for our tastes, which is why we yearn to do something even cooler. Artificial intelligence and machine learning have been at the forefront of computer science talks recently, and for good reason. This year, we wrote our own custom machine learning code to attempt to identify how many rings are in front of the camera and more. Here's how we did it. To start off, we use something called a neural network. A neural network is a mathematical model modeled after the human brain that is one of the most advanced methods of emulating natural human intelligence in a machine. It works by using thousands of interconnected neurons to process numbers. It takes in multitudes of training data to then memorize the relationships between the data and predict a desired output based off of its memorization. There are libraries out there that will help you make a very easy neural network, such as TensorFlow, but we chose not to use any of them to maximize the amount of knowledge we gained through this project by coding our network from scratch. Currently, our neural network to detect rings is almost done, and we hope to finish it by the end of the season. We're also in parallel designing a neural network to identify whether the tower goal is in the image or not, with the ultimate goal of the neural network telling us where the tower goal is located in an image so the robot can align itself. This sort of project takes a lot of time, effort, and computing power, but it's well worth it in the end. We've gained so much knowledge through this project, and we'll be able to build it into future seasons a lot easier now that we've laid a groundwork for the initiative. As you can see, we've done many interesting and innovative things this year when it comes to our control systems that we're really proud of, and we can't wait to see what we do in the future.